Okay, simplifying radicals, we're going to separate that 80 into what's called perfect squares and imperfect squares. Or not perfect squares, right? What do I mean by perfect squares? Anybody know? Anybody? Anyone? 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 Bueller? Bueller? Anyone? Anyone? Bueller? Bueller? Dewey, are you Googling it or what? What do I mean by perfect squares, guys? Well, think of it. Squares. Perfect squares. Okay? If I have the number 1 squared, what's 1 squared? 1. If I have the number 2 squared, what's 2 squared? 4. 2 times 2, right? 3 squared? 9. 4 squared? 16. 5 squared? 25. 6 squared? 36. 7 squared? 9. 8 squared? 9 squared? And 10 squared? 100. That'll be good for this class. When you get to Algebra 2, you're probably going to be expected to do it all the way to 20 squared. Okay? At least 15 squared. Now, these products, all of these squares here, these are our perfect squares. Okay. So, going back to my square root of 80, I'm going to break it up into perfect squares and imperfect squares. Now, the book, there's also another way of doing this. I'm going to show you both ways. This is actually easier. Okay. Now, instead of starting all the way, well, I'm looking at the number 80. Instead of starting at 64, now you could, it's not a big deal. Take your calculators, and I'm going to take 80 and divide it by 64, and if it comes out a whole number, I know that 64 is a perfect square. Hit enter, I get a decimal. So I know 60. Oh, okay. I know 64 is not a perfect square, that's a factor of 80. So I'm going to go down to the next one, 49. So I'm going to take 80 divided by 49. I got another decimal. 49 is not a factor of 80. Keep going down on my perfect squares. 36, 80 divided by 36, another decimal. I'm going to try 25, 80 divided by 25, another decimal. 80 divided by the next one down, 16. Hit enter, and I get the whole number 5. So 16 is the largest perfect square that goes into 80. So I'm going to break this up to the square root of 16, my perfect square, times the square root of my imperfect square, which is the other factor, 5. Now I can simplify this. Square root of 16, well, that's easy, it's 4. And then I don't need the multiplication symbol there, square root of 5. So that is the square root of 80 simplified. Right, Sergio? You guys need to focus on this. This isn't easy stuff. You know about this? So you can do the square root of 180. Okay, pay attention. Now, if you noticed, I started at 64 because that's the first least perfect square that's less than 80. I could have started even less than that because I know that this is going to be multiplied by at least the number 2, right? because I got to have two numbers to multiply to 80, other than 1 in itself. So I could have taken 80, divided it by 2, which is 40, and started at 36, cut down a lot of my work. Does that make sense? All right. Here's what I mean. I get to a problem like the square root of 180. Instead of starting, well, I would have to continue my perfect squares all the way to 180. Instead of doing that, right off the bat, I'm going to take 180 and divide it by 2 because I have to have at least two factors. So this equals 90. Okay. So now I'm going to start with the perfect squares less than 90. So I'm going to take 180, divide it by 81. So I'm going to have my perfect square here and my imperfect. So I'm going to start at 90. The first least perfect square, the biggest perfect square is 81. So I'm going to take 180, divide it by, see, I'll move it over here. 180 divided by 81. Oops. Get a decimal, don't even care about what it is. Go down to the next one, 180 divided by 64. Decimal, so try 49. 180 divided by 49. Another decimal, 180 divided by 36, and I get 5. So my perfect square is going to be 36. My imperfect one is going to be 5. What's the square root of 36? 6 square root of 5. Right, Sergio? Easy now. How about 54? What's half of 54? Anyone? Anyone? Bueller, Bueller, Bueller. Anyone? 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 54 divided by 2. Bueller. Yes?
I don't know.
I don't know. Sergio. 27. Okay, so 54 divided by 2. Okay, 27. So the first largest perfect square that's less than 27 is 25. And go through the whole process. 54 divided by 27 equals 2. Oh, what am I doing? 54 divided by 25, I'm sorry, the largest perfect square. And the decimal, keep going. 54 divided by 16, decimal. 54 divided by 9, 6. So there's my perfect square. Square root of 9 times the square root of 6. The square root of 9 is 3. Square root of 6. Here's my answer. Now, the book does show you another way. Everything except prime numbers is going to be divisible by what two numbers? Every number except a prime number. A prime number is a number that can only be multiplied by itself in the number 1. Right? Every other number can be multiplied by 2 or 3. Right? So here's what your book does. 54 is an even number. So I know that it's going to be divisible by 2. In fact, we get 2 and 27. So there's a property called the product property of square roots that says I can take whatever's underneath this radican, or radical, the radican's called 54 is the radican, and split it up between factors. So I can actually rewrite this as the square root of 2 times 27, or square root of 2 times the square root of 27. But I'm going to use this simplification here. Not simplification, but property. Okay. What else can I multiply or divide into any of these numbers? Again, it's either going to be divisible by 2 or 3, or it's going to be a prime number. 27. I can divide it by 3, right? So that's 3 times 9. 27 is 3 times 9. Okay? So what the book calls, well, what the book uses is called prime factorization. Okay? I'm getting everything down, all the factors down to its prime numbers. Now, the 9 I can divide by, you guessed it, 3 times 3. Okay? So here I can put these two 3's together, call it 3 squared, right? Or 9, and then the rest, 2 times 3, and this one, I'm ahead of myself. The square root cancels out this squared, leaves me with 3, 2 times 3, the square root of 6. Now you tell me which way is easier. Yeah, the first one. Okay? Splitting it up between perfect square and non-perfect square. Okay, 2a. Look at next page, number 2a. So I'm going to multiply everything under the radical symbol. So I have the square root of 5 times 10, square root of 50, and afterwards I have to simplify to perfect squares and non-perfect or imperfect. Okay. Means I'm going to have a square root here and a square root here. What's 50 divided by 2? 25, right? So this becomes 25 times square root of 2. I'm going to start with the largest perfect square that's less than 25. So look under here. Hey, look, 25 is a perfect square. Okay. So I could go ahead right now and just take the square root of that, which is 5. Very good. So the square root of 25, 5. I'm sorry, I'm just going to put the 25 there. And 2. Now I'm going to put the square root of 25, 5, square root of 2, and I'm done. Unless you guys want to do prime factorization, which I don't think you do. Okay, to be or not to be. Square root of 6 times 8. Boy, you guys are just really slow. You know, today's National Nap Day. I think you guys need a nap. Okay, square root of 6 times 8 is the square root of 48. Are you on your phone, Esco? Why? Well, just give me 5 more minutes, and then you can play your music as long as you're doing your math. Okay, half of 48. 48 divided by 2 gives me 24. I'm going to start there. Okay. The highest perfect square less than 24 is 16. So I'm going to take 24. I'm sorry, not 24. 48, and divide it by 16, and I get 3. Look at that. Right off the bat, I get a perfect square. 16 times 3. And the square root of 16 is 4, square root of 3, undone. Quotient property. What do I mean by quotient? Quotient. Anybody? Anyone? 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 Bueller? 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 What do I mean by quotient? Division. It's National Levi Day. Okay. Well, we can as long as there's no gold stitching or 5 pockets. Okay. What the quotient property tells us that we can do. Esco, sit out. Esco, sit out. The quotient property says if I have an entire fraction underneath a radical, I can split it up to the square root of a over square root of b and solve for a and b. Now, here's remember at the beginning of the lecture, I told you guys that you can never have a radical in the denominator. This is where it becomes a real pain in the butt. Yes, pain in the butt. Okay, for instance, if I have the square root of 6y over the square root of 12, we're not going to worry about the y for now. Now, there's no way I can simplify square root of 6 because it's 2 times 3. It's already, it's a prime factorization right now. But I can simplify 12, all right, square root of 12. What's the largest perfect square that goes into 12? Is 6 a perfect square? Let's check our chart here. Is 6 a perfect square? Nope. I don't see a 6 on here. I could try 9. 12 divided by 9. Nope. 12 divided by 4. Look at that. 4 times 3. So 4 is a perfect square. And I have radical 3 left over. So I'm going to rewrite this. Square root of 6 over, what's the square root of 4? 2. Square root of 3. Now, I can never leave a radical in the denominator, right? So what do you suggest we do? Any ideas? Anyone? 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 By the way, this is a side note here. This square root sign, square root of 6, is in, this is radical form, this is exponential form. Okay, 6 to the 1/2. This is going to help you. Now, when I multiply two numbers with the same base but different exponents, what do? What, Esco? What do I do, man? You know this. We did this about 2 months ago. we added the exponents, right? So I get x cubed. So what I'm going to do here is multiply this by radical. I'm just going to multiply it by the number 1, radical 3 over radical 3. And think of this as 2 times 3 to the 1/2. And then I'm multiplying it by another 3 to the 1/2, right? Radical 3. Hurry up. All right, so here on the numerator, I have radical 6 times radical 3. In the denominator, I have 2 times, well, 3 to the 1/2 plus 1/2 is 3 to the 1st. Okay, now I get radical 6 times 3 is radical 18 over 6. Look at that, we're almost done. Radical 18 I can bust up, though, into a perfect square and a non-perfect square, right? What are you doing? Square root of 9 times the square root of 2 over 6 becomes 3 square root of 2 over 6, and I can still simplify. 3/6 is 1/2, so I have 1 square root of 2 over 2, and I'm done. Do you see how this gets really lengthy and hard when we get into this whole can't have a radical in the denominator? We're going to be doing a lot of these problems because it takes a while to get this down. No. Can I ask you a question? Why do you have a multicolored monkey with you?
I seen a lunchroom one day. It was on the table.